Okay, so from the title, and possibly from the question, what's different about this one from what we've done so far?
It's an inequality instead of equality.
We're doing inequalities. If you remember when we did polynomial inequalities, it was a very different method for solving those, right? We did the sketch and read the answer off the sketch. Not what we're doing for this one. We're not sketching. In fact, these ones are a lot like the equations, one of the types of equations that we did yesterday. That part is fairly straightforward. It's going to feel very familiar. The challenge to these ones is interpreting the answer and writing the answer correctly. That's the whole challenge for this, okay? So there's a few different ways that you could do it and think about it. And depending on you and your preference of things, you might do it one way or another. I'm going to show you one method that I think is a good way of sort of organizing and thinking. It's at least a good way for me to show my thinking, like on paper. You know what I mean? So that's what we're going to do. And I think you want to be focusing on that interpretation and thinking about that and making sure you understand that. Okay? All right, let's try the first one. So the setup is the same as what we were doing. We do case 1 where 2x plus 3 is less than 0, which is when x is less than negative 3 over 2. And 2x plus 3 is greater than or equal to 0, which is when x is greater than or equal to negative 3 over 2. Okay, the one where the argument of the absolute value is negative, we put a negative out in front. See how this is all the same still so far? So yesterday we did two types. We did the single absolute value and then the double absolute value. This is like the single absolute value. We don't do double absolute value inequalities, thankfully. And then this one, you leave it alone. Then we just solve them. What's next? What do I have to do next? I know you're all kind of working away on your own, but... When I divide by negative 3, I have to flip the sign. Good. Okay, everybody caught up to me so far? Here's where the tricky part comes in. I have to look at these intervals in the two cases and put them together to figure out what our solution is. Because when you have inequalities, you have more than one solution. It's not like x equals 5, right? Our solution is a set of numbers. So this one means numbers that are less than 3 over 2 and greater than negative 8 over 3. Both. It has to meet both. And this is numbers that are less than 2 and greater than or equal to negative 3 over 2. And then we're going to take both of those and we're going to combine them together if we can. Do you have a question? I don't want you to answer it, but do you have a question?
No, just a thought about it.
Okay, maybe you can hold on to it and I'll get it back from you after. So here's the method that I'm going to suggest we do. We're going to draw a number line. The other tricky thing about these questions is there's a lot of different outcomes that you can get. There's all kind of like the double absolute value where, there's lots of different things that you might see and you have to interpret them. Same thing here. Okay, but because they're inequalities, the interpretation is even that much more challenging. Okay, so every question is going to be a bit different. For this question, there are 3 numbers that we need to put on our number line. Okay, they're going to be negative 3 over 2, negative 8 over 3, and 2. Those are the numbers we need on our number line. And eventually you're going to have to be the one who knows what numbers to put on. So what is negative 3 over 2 as a decimal?
Negative 1.5.
And what about 8 over 3? Use your calculator. Yep.
Negative 2 and 2/3.
So negative 2.67, something like that, right? So you got to make sure you get the numbers on the right side of each other. Okay, the number line is a number line. They need to be in order, like we've talked about before. But again, there's going to be fractions in this math. And so writing out the decimal version of the fraction might help you make sure that you've got things on the right side of each other. And sometimes one's positive and one's negative, so it's easy, but not always, right? So this looks to me like negative 3 over 2 is in the middle. You'll probably notice that this number is often in the middle, but it's not always in the middle. So you do need to think about this and make sure you're doing it correctly. 2 is to the right, and negative 8 over 3 is to the left. Now I'm going to use highlighters because my computer happens to have them and they work out really nicely. You don't need to use highlighters. Some people in the other class were just using colored pens. You can just use a single pencil. Okay, like there's different ways that you can do this. Sometimes when I used to do this on paper and I didn't have all the fancy colors, I would do this. Okay, but I'm going to use these highlighters and I'm going to do that because I think it also helps me demonstrate what I'm doing and share my thinking with you. Okay, so that's what I'm going to do. So, and I'm going to start with this one. And I'm going to draw above my number line. Again, this is just how I do it. The number line is not something that I'm going to mark. I'm going to mark your solution. So this is for you to keep track. Some people might not even need a number line if you're good at understanding these things. All values that are less than negative 3 over 2. It doesn't include negative 3 over 2, so I use an open circle. And I'm going to draw less than. Now I'm moving to a new color. And I'm doing this. And those are from the same case. So I'm putting those together above the line. Again, this is just how I do it. And this is all values greater than negative 8 over 3. So again, it's an open circle. And I'm going this way. Where do those two overlap, if anywhere? Like you can see it. But mine's cool because it actually changes color, right? But you can see where they overlap.
In between negative 8 over 3 and negative 3 over 2.
Yeah, but not including them, right? So I'm going to write that here. Negative 8 over 3 less than, I should have left more space so I could write here, less than x less than negative 3 over 2. That's what that interval is. And that is the solution of this case. Okay? Numbers have to be less than negative 1.5 and bigger than negative 2.7. So the numbers between them, right? That makes sense. If it was like, it's a little bit harder because it's negatives and fractions. But if it was numbers that are less than 5 and greater than 2, then it's all the numbers between 2 and 5, right?
Would it not include negative 3 over 2?
Nope, because this didn't include negative 3 over 2. So these are both empty. It's got to be everywhere. If one of those circles was colored in, then it would be included. Okay, now I'm moving on to another color. You could reuse the same colors. And I'm moving on to the second case. X is greater than or equal to negative 3 over 2. Greater than or equal to is a colored in circle. This is a standard in mathematics. Open circle means you are excluding the end point. Closed circle means you're including the end point. Okay, and it's greater than, so I'm going this way. And then this is x less than 2. Not including 2, so open circle, and this way. Now take a look at the difference here. So Ava, when you asked about wouldn't it include that, see how it does include it here, but it didn't there? So in the end, you're going to get that point in your solution, but to be careful and to be specific, it's not until we get to the bottom part. Okay, so what's the solution for the second case? Yep.
Negative 3 over 2 is less than or equal to x, which is less than 2.
Very good. Negative 3 over 2 is less than or equal to x, which is, strictly less than 2. So at the top is the solution to the first case, at the bottom is the solution to the second case. Do those solutions overlap anywhere in a way that we can combine them and write them as a single statement? So I'm starting here, and I'm going through here, and I'm including that because it is included in the second one, and I'm going all the way to there. That's my solution if I combine the two. So what would that look like as our final statement? Yep.
Negative 8 over 3 less than x less than negative 3 over 2.
Okay, keep going.
Less than or equal to x less than 2.
Okay, so we don't usually write it more than one all together in one statement, but I don't think we need the negative 3 over 2 part.
Just less than 2.
Because that'll include it, right? Yeah. So we can just go straight to the 2 and write it that way. Sometimes you can combine the statements, and when you can, you should. Sometimes you can't, so you just write them separately. Okay? I'll talk about this again because this is only the first time you've seen it and it might not make a lot of sense yet, but when you're looking for the solution to the case, it has to satisfy both of these, right? It's not one or the other. Numbers that are less than negative 3 over 2 and greater than negative 8 over 3 would be all the numbers. If it was an or this, but this is an and. It has to satisfy both. It has to be this and this. And same for the other case. But when I'm combining them, it becomes or. It's one or the other. Okay? Any questions? Yeah?
So my thought was kind of right, because what I was going to say is, could you combine the two statements for each case into one line?
Yeah. So, and you could, like, if you're good with numbers, you might be able to do that without the number line. You might be able to just say in your head, numbers that are bigger than 2 and less than 5. Well, that's from 2 to 5. And then you might be able to add in the other, like, right? So you may not need the number line, but most people use it. It's a good tool, so I would recommend using it. Okay. All right. So, again, you know how to do this. You can kind of do this first part together, and then I would recommend we do the number line, or you can do the first part on your own. We do the number line together until we've done it a couple more times. Again, I'm dividing by a negative, so I flip the sign. I want you to watch for a minute. Some people get confused about where the inequality signs come from. The inequality signs up here are the ones that you are setting up. So remember, one of them has to be less than, one of them has to be greater than, and one of them has to include 0. I always do the one on the right, but you can do whatever one you want. So I always do this one as less than, and this one as greater than or equal to, and then when you solve it, if they flip, that's fine. These signs, come from the question. They have nothing to do with what's happening up there. The signs down here are from the question. Okay, don't confuse the two. And they will flip if they have to flip, or they won't if they don't, or whatever, but that's how the setup is. Okay, let's solve these. Okay, so when you get caught up to me, we're going to do our number line. What are the three numbers I need to put on the number line? If there are three, Evan?
1.752 and 3.5.
Good, and you gave them to me in order. I like that. So 1.75, which is 7 over 4. 2 is in the middle again. Remember I said it often is, but not always. And I'm spacing them out a little bit better this time. 5 over 2 on the right. Again, those have to be in the correct order. Somebody was asking a question about their work earlier today, and they couldn't figure out why their answer was wrong, and it's because they had 2 of them out of order. And usually it's if they're negatives, and usually if they're fractions. And so you want to do the decimal can help with that. Is everybody ready? You could try to think about it yourself, but we're going to do this one together, like I said. So this is x values that are greater than 2 and not equal to. Whoops, I got to make sure that you can see the whole. And x values that are greater than or equal to 5 over 2. So what is that solution? Where do they overlap? And where else? And onwards, and bigger, right? So this is x greater than or equal to 5 over 2. X less than or equal to 2. X less than or equal to 7 over 4. So this is, where do they overlap? You can see where the color changes. I don't know what color that is. Gray? Yeah.
When x is equal to or less than 7 over 2.
Good. And then we always write our final therefore statement. Can we combine those two? Can we write them as a single statement? No. Right? They don't meet up in the middle somewhere, so we write them separately. So x values that are less than or equal to 7 over 4, and x values that are greater than or equal to 5 over 2. Any questions? Yes?
How were we able to combine them in the last question?
How were we able to combine them in the last question? Let's take a look. Because they met in the middle. because this one was up to negative 3 over 2. And this one included 3 over 2 and kept going, if you think about traveling along a number line. So they met at negative 3 over 2, so we could combine them together. Like this solution comes from over here, and this one comes from over here. They're totally separate, right? So you can't combine them. Whereas these ones are both in the middle together, and they do meet up. You could have a situation maybe where they don't meet up, but that one did. Okay, so I want you to try to set this one up on your own. You should be pretty familiar with it by now with all the work you did with it yesterday. That's what I have so far. And then you're going to solve each of them. Okay, and that's what I got. Anybody got the same? You might have moved the negative 3 over and got this instead. People do that. That's fine. Okay, same thing. What does that mean? Never true? What were you going to say, Nora? Same thing? Gwyneth, what do you think?
Actually, it's always true because negative 3 is, well, no, it's not equal to though.
Ah, interesting question. So which one is it?
Well, negative 3 is less than 5, but it's not equal to.
I know, so which one is it? It's less than 5, but not equal to 5. Does it have to be both less than and equal? I mean, nothing is less than and equal. It's less than or equal. That's even how we say it. So this is always true because negative 3. People think it's not true because it's not equal. It is true because it's less than. Okay, it does satisfy that inequality. So this is always true. Negative 3 is less than or equal to 5, namely because it's less than 5. What does that mean? What do you think?
Then when x is greater than or equal to 3, it's like a line that's on top of the other line.
So in this case, it's not necessarily on top because it's just greater than or less than. But you're right in the sense that when x is greater than or equal to 3, it'll always be true. So this entire case is going to be a solution. Okay? So you don't necessarily have to do it in the number line. I'm still going to, but you may not have to. I'll show you how you could show it in a number line, although some people get a bit confused by it. But we're going to give it a try. Okay? So, number line. I don't have 3 numbers this time. This doesn't count. Okay, it's only the statements that have an x in them, because the lines we're drawing are like our x. So I got to do 3 and -1. For the left case, it's when x is less than 3. And where x is greater than or equal to -1. Remember, folks, I'm not marking your number lines. The number line is for your thinking. When x is greater than or equal to 3. How do I show always true? Yeah, very good. You just go straight across the whole thing, wouldn't you? That's what always true means. This equation is true for all values of x. So the entire number line. So much clicking and clacking as the pens are opening and closing. It's hilarious. Okay, so the top one. What's my solution there? I want everybody to think about it. You don't have to write it, but I want you to think about it. Just look at that and say, where do they overlap? Because it's easy to think about it wrong when you're doing it for the first time. So you got to do it a few times until it clicks. Amara, what do you think? Good. That's where they overlap, right? So the yellow goes over the -1, and the -1 is colored in, so we include the -1. But the yellow on this side isn't colored in, so we would not include the 3, but we do go up to it because the blue goes all the way up and past. That's where they overlap. Again, numbers that are bigger than -1 and also less than 3. Isn't that these numbers? Okay, and then the bottom one is where they overlap. So that's where x is greater than or equal to 3. Remember I said it's just that whole interval, that whole case is a solution. Is this a question, or are you going to tell me what to write next?
It's a question.
Go for it.
What would that look like on a graph?
That's a good question. Let's finish this one, and then I'll show you, because I think I have something ready that we could actually type it out. Yep.
You can combine those two to x is greater than or equal to -1.
So this one starts at -1, includes -1, goes up to 3. But then I also have 3 because it's included here, and everything bigger than 3. So this is x greater than or equal to -1. There are stages of understanding here, folks. The setup we should be familiar with, so that part I hope is okay. Drawing the number line and getting these two is the first stage of understanding. If that's where you're at right now, that's good. Then you can start to add in trying to combine them. Yep.
What if you forget to do that on a test situation? Would you be docked marks, or would you just get them?
Yeah, you should be combining them. Yep. Okay, so this is the absolute value of x minus 3. And this is just x plus 5. So the point is, x plus 5, the line, is above or equal to that absolute value function. The x plus 5 is the blue. The absolute value of x minus 3 is the green. When are the y values of x plus 5 greater than or equal to the other one? And it looks like it's at -1. right? So if I do this, it's going to shade in the area where it's bigger. Like it's showing us that the blue is above the green. If we flipped it the other way around, it would be the other spot. Okay. Any other questions? Again, you can set this one up. There's the setup. There's my solution. What are the numbers that I need on my number line? -1 and 2 and 1. Yeah, good. Oh, okay, -1 and 1 and 2. And that's the order. So notice the 2 isn't in the middle this time. So just the way the algebra works out. Okay, so -1 and 1 and 2. Okay, so doing the first case, values of x that are less than 2, starting at 2 and going less than. Values of x that are less than 1, starting at 1 and going down. So what's the solution to that top part? What's the solution to the top part? Noor? X less than 1. Very good. Because we don't include 1, and then they overlap. Like, you don't need to use highlighters. You could just use arrows like that, right? And you could color code them or not. Like, that's up to you. Okay, next one. Greater than or equal to 2. X values less than -1. What happened there?
Does that mean it's extraneous?
Yes, there are no solutions here, so it's like extraneous. The x less than -1 is extraneous. It's not within that domain at all. Okay? I'm just going to say no solution. Whoops. Because there's no overlap of those areas. So therefore, our overall solution is good, x less than 1. Lots of different cases, that like lots of different things that can happen in these questions. You see what I mean? That's what I said at the beginning. Every question's a little bit different in how you interpret. There are some common sort of outcomes, but there are some that can be very different. Like, look at this one. These are two that are going the same direction. So they're going to overlap somewhere. These are two that are going opposite directions, and they start like outside each other. So there's no solution there. These are ones that are going opposite directions, but they're going towards each other. So there's going to be an interval between them where they cross over, right? So all kinds of things can happen. Okay, this is the last one. This one's funny, and once in a while this will come up on a quiz or a test or something, and don't write this down, but people will do this. Ready? What am I doing that's wrong here? I didn't do the absolute value. Why do you think somebody would do this? What?
So they're so used to seeing the absolute value come first.
Yeah, because usually it's on the left. And so we kind of just we think x plus 1 is the one that we have to do it with. This doesn't make any sense. The whole reason why we've been setting one of the cases less than 0 and then putting a negative is because of that absolute value thing. So this should be x plus 3 less than 0, of course, right? Again, everybody knows that and thinks they won't be the one who does it, but then you're rushing on a test and you end up doing it. So be careful. Okay, and you can keep going and you can keep solving. Okay, so something interesting happened there. We've kind of seen this before, but okay, so let's do our number line.
How did you get 1 less than equal to 1? I got 0 less than equal to 0.
You must have moved the 1 over and I left it where it was. So I left the 1 alone and did 3 minus 2 to get 1. Both are fine. I could multiply both sides by 5 and say 5 is less than or equal to 5. I could subtract 1 now and get 0, right? Like you could still, it's weird because there's no x, but it's still an inequality or it's still an equation. You could still do operations, whatever you do one side, you do the same to the other. It is a little bit strange, but okay. So again, 1 is not one of the numbers that I need in this situation. That's not what the 1 means. I only need to use the numbers that have an x in them because we're talking about x's. So what do I need on my number line? Negative 3 is the only thing there. Everything worked out to negative 3. So where do you think I'm going to put it? In the middle? So I'm going to do the case on the left first. X is less than negative 3. X is less than or equal to negative 3. So one of them's colored in, but the other isn't. So you can only include it if it's in both. So we're not including negative 3, but the solution to that side is x less than negative 3. And this is x greater than or equal to negative 3. And 1 equals 1. That's always true again, right? We did not talk about that, but that's true. We sort of started talking about it, and then I guess I moved on. 1 does equal 1. So we saw another case where it was less than, and that was always true. This is equal to, so it's still always true. You could have one that's never true. That's possible. Okay. Okay, so what's this? Oh, so I got to finish this. So always true means everywhere. So what's the solution to this side? Noor? Good. X is greater than or equal to negative 3 because the always true is everything, so it's just this interval. And again, negative 3 is colored in. It's included in both, so we include it. So what's our solution? Can we combine these? Evan, what do you think?
Is it negative 3 is less than x, which is greater than or equal to negative 3?
No, because you can't have your signs in those statements pointing opposite directions. Maddie?
X is the element of the real number.
It's everything. I've got all the ones that are less than negative 3, all the ones that are bigger than negative 3, and negative 3. So therefore, x is an element of the real numbers. Any questions? Seems tricky, but again, it's one of those things that is new, so it seems weird at first, but after you practice, you force yourself to try to think about it, you will be able to do this. It's not undoable for sure. Okay? No questions?